You think you know what a surface is, right? I mean, it's the top of your desk, the floor you're standing on, simple. But what if I told you that out there, in the mind-bending extremes of the universe, that simple idea just completely melts away? Today, we're diving into a question that sounds basic, but is anything but. What in the cosmos is a surface?
So, to really get our heads around this, let's ask a more direct question. Picture a star, blazing in space. Where does it end? Where's the edge? It feels like there should be a straightforward answer, but you're about to see that the universe has some very different and very strange ideas.
And here's the thing. The problem is our own intuition. It's playing a trick on us. Our everyday concept of a surface is really just an illusion. It works great for us here on Earth, but it totally breaks down when you start looking at the most compact, most powerful objects out there.
Yeah. See, we think of a surface as something solid, defined, hard. You can knock on it. But in astrophysics, a surface can be this fuzzy quantum cloud with no real edge. Or it could be a one-way door in spacetime you wouldn't even feel yourself passing through. Or it could be a place where the fundamental laws of physics just suddenly change.
Okay, so to really unpack this, we're going to go on a little cosmic tour. We're going to look at 4 radically different types of boundaries. And our first stop, well, it's the one that feels the most like home.
First up, the hard surface. This is our classic intuitive idea of what a boundary is. It's a sharp, clean transition where matter just stops and empty space begins. Think of it like a solid wall at the edge of an object.
And yeah, a hard surface acts exactly how you'd think. Anything that smacks into it just stops dead, sending shockwaves through the object. Light and other radiation either bounces right off or gets completely absorbed. It is a definite, no-nonsense barrier.
And the best example we have of this? A neutron star. This thing is so unbelievably dense, its surface is basically a crystalline crust of super-compressed matter. It has a real, hard edge that you could, theoretically crash into.
All right, now let's get weird. Our second stop is the soft quantum surface. Okay, so forget the solid wall. This is more like a cosmic fog. There is no sharp edge here. Instead, the density of the object just kinda peters out, gradually fading into nothing.
And this is where the physics gets seriously strange. See, on this quantum level, particles don't have one single location. They exist as a cloud of probabilities. So the surface isn't really a place. It's more of a statistical likelihood. Things don't bounce off. They just kind of fade in, getting gently absorbed as they move through this fuzzy zone. Now, we haven't actually found one of these for sure yet, but our best guess for where you might find this kind of surface is a theoretical object called a boson star. It would just be this giant fuzzy cloud of exotic particles, with no clear beginning or end. So we've gone from a hard wall to a fuzzy fog. Now let's go to no surface at all. Our third type is probably the most famous boundary in all of science, the event horizon. Now this is absolutely crucial to understand. An event horizon is not made of anything. It's not a physical thing you can touch. It is a point of no return woven into the very fabric of space-time itself. The rules here are devastatingly simple. Anything can fall in. Absolutely nothing can ever get back out. Not even light. There's nothing to crash into, nothing for a signal to echo off of. It's the ultimate one-way trip. In fact, if you were falling through it, you wouldn't even know when you crossed the line. And of course, the classic example here is a black hole. It is the perfect illustration of an object with no surface whatsoever, just this eerie, invisible, inescapable boundary. Our fourth and final type is maybe the most exotic of all, the phase transition layer. I want you to imagine the surface of a frozen lake, right where the water turns to solid ice. It's a place where the rules that govern the water molecules suddenly change. Well, this is like that, but on a cosmic, relativistic scale. Across this incredibly thin layer, things like pressure and density can just jump radically. It's an interface that's held together by this really tense balance of forces. It's not a boundary between matter and nothing, but between two totally different states of reality. This kind of wild boundary is predicted to exist in another theoretical object, a gravistar. It's a proposed alternative to black holes. So instead of an event horizon, it would have this bizarre paper-thin phase transition layer at its edge. Okay, so we've met our 4 contenders for the title of Cosmic Surface. Now I think it's time we put them side by side in a lineup and see how they really compare. Looking at them like this, wow, the differences are just crystal clear. You see, the hard surface is the only one with a truly sharp edge. And look at locally detectable. You could drift right past an event horizon and have no idea.
And check out that last row, EOS change. That's the equation of state, which is just a fancy way of saying the rules for how matter behaves. Only the phase transition layer is defined by those rules suddenly changing. It just goes to show how different these ideas really are.
Now, this is all fascinating theory, but how can we actually tell these things apart when they're light years away? How do we actually listen for the echoes from the very edge of reality?
Well, it's basically a two-step process. First, scientists look for specific signatures. You know, a hard surface should reflect things, right? So we'd look for reflected light or X-rays. A black hole's event horizon should create a very clean gravitational wave signal when something falls in, with no echoes at all. And then, for step 2, they use these incredible instruments, like LIGO, to listen for those gravitational waves, or the Event Horizon Telescope to literally try and take a picture of the boundary itself.
So, after this whole cosmic journey, what have we actually learned? Well, it turns out we need to completely reboot our definition of what a surface even is.
And this really gets to the heart of it. In modern physics, a surface isn't really a place. It's more like an answer to a question. And that question is, what happens to information when it gets here? Does the information bounce off? Is it absorbed and scrambled? Or is it trapped forever behind a one-way door, lost to our universe? That's the real question a surface answers.
And this is where our simple, everyday intuition just shatters. We've seen that a surface doesn't have to be something you can touch. An edge doesn't have to be a specific location. And a boundary? Well, a boundary isn't always a wall.
Which leaves us with this final, frankly mind-bending thought to chew on. Out there in the vast, strange cosmos, not every object even has a surface. And maybe, just maybe, not every surface we can possibly imagine is actually real.